Hey everyone, today we are going to see the two sum problem in the LeetCode. So it's a pretty easy problem. I just wanted to jump into the problem right now. So given a number and given a target, we just wanted to find two numbers in an array such that the summation of the two numbers will reach up to the target. And there is a thing which is like you may assume we have only exactly one solution and you may not use the same element twice. Let me first ignore these two conditions and let me just write the problem statement. Given the array and given the target of 9. So just to find two indices which will be summation up to the target. I just wanted to go in a mathematical approach first of all. So how can you solve this one if it's a mathematical problem? So what will you do was you'll be trying to generate all possibilities and check whether the summation of two elements, that is let us assume two elements which is of a plus b, will leads to the target or not. So seeing it in a pictorial fashion, you'll be just starting with the two and you'll be exploring all the possible elements that are being present. That is, with the two, you'll be again adding the two and you'll be adding the 9, you'll be adding them with the 11, you'll be adding them with the 15, followed by you'll be seeing the second number and you'll start adding with all the numbers. Since we have already been added 2 with the 7, so the 7 with the 2 it leads to the same things. So which is of the same 9. So 9 and 14 here. I'm not concentrating on the values. I'm just focusing more on these things. So 11, which is nothing but 13, 18, 22, 17, 22, 26. So similarly, the same values will be repeated at this half of the side, 30. So the same values will be repeated here also. And if you observe few things here, this is the region where both elements are in the same locations. And if you wanted to say in a algorithmic manner from the mathematical things, assume you have been standing at one position and there is one more pointer where you will be standing on, and this pointer will be keeps moving on forward. That is, let me take down this table into a new page. Okay, so you will be having a pointer known as I pointer, and let me write the indices for this array for making more clear. And let me just take the color coding of J. So what's happening was at I equals to 0, you'll be standing in the 2 position itself. Now developing the algo part. And J here you will be standing in the 2 position, followed by you'll be going through the 7, 11, 15, like that. So whatever the things that is representing here, is nothing but j equals to 0, 1, 2, 3. Now exploring that one, you'll be exploring all the possible parts. And now you'll be standing in the first index. Even now you start exploring all the possible positions of j. That leads to this summation. And you'll start standing in the second index. Again, you'll start exploring j equals to 0, j equals to 1, 2, 3. So, and you'll be getting the summations for that one. So, are nothing but these lines. And again, you'll be standing in the third index. And now, you'll be exploring all the possibilities. And you'll be getting the summation, which is of in the last line. So, this leads to I equals to 3. Here comes a few observations. If you observe this part of the region, in this region, if you observe I value equals to 0 and j value equals to 1, 2, 3. Similarly, in the second row, when I value equals to 1, j value equals to 2 and 3. So let me just mark it down, which part of the region is. So this part of the region I'm just talking about. So this is a region where j value will be always greater than I. And there is one more region which is of the counterpart, which is of this region. In this region, I value will be always greater than the j value. So the algorithms from this one is like, if you are standing at one position, from the next position explore till last, which is a forward kind of things. And at I greater than j region, the algorithm is, when you're standing at one particular position, from the starting, explore up to that region. So which is nothing but relative to I, it is moving forward. Relative to I, it is moving up to I. So it is just expecting the future data. It is again re-exploring the past data. So this algo will leads to the, any of these two algos will leads to the brute force approach. Personally, I'm just taking this as a brute force approach algorithm because this algorithm has some sort of pros in this one. You can observe that pros when you are just diving down into the optimal solutions.